Quadratic functions in vertex form. This lesson will focus on identifying quadratic functions in vertex form, determining the effect of A, P, and Q on graphs of quadratic functions, and on analyzing and graphing quadratic functions using transformations. A quadratic function is of the form f of x equals any polynomial of degree 2. For example, we could have f of x equals x squared, or f of x equals 3x squared plus 2x minus 1. Both of those are examples of a quadratic function. The simplest form of a quadratic function is f of x equals x squared, or we can write it as y equals x squared. We want to have a look at what the graph of this function looks like. So to graph it, we are going to guess or pick some values for x. I'm going to choose -2, -1, 0, 1, and positive 2. To calculate the y value, we're going to substitute in -2 in for x squared. -2 squared is positive 4. Continuing to fill in our table, -1 squared is positive 1. If x equals 0, we get 0. If x equals positive 1, we get 1. And if x equals positive 2, we get a value of 4. Let's have a look at the graph of this function. To graph this function, I can plot each of those points. So the first one is -2, positive 4. The second point is -1, positive 1. The third one is the point 0, 0. Then we have 1 and 1, and 2 and positive 4. If we connect those dots, we end up with a shape called a parabola. The vertex is the lowest point of the parabola if it opens up. So ours is said to be opening up because the arms point in this direction. That makes this lowest point down here our vertex. If our parabola was shaped so that it was opening down, the vertex would be this highest point. We also have a line that is called the axis of symmetry. The axis of symmetry is the line that divides our parabola directly in half. We can find the equation of that line by looking at the point or the x value that graph goes through. So we look at our coordinate plane. Here's our y-axis. Here is our x-axis. So if we went over 1, 2, 3, 4, 5, 6, 7 points, this coordinate would be -7, 1, 2, 3, 4, 5, 6, positive 7. Therefore, the axis of symmetry for this parabola will be the line that goes through x equal to -7. When we look at all of our parameters together, they all tell us something. So y equals ax minus p squared plus q is called vertex form. When a quadratic equation is written in vertex form, A, P, and Q tell us specific information. Let's start by looking at A. A will determine if our parabola opens up or if it opens down. Our parabola will open up if our A value is positive. It will open down if the A value is negative. A also tells us whether our parabola gets wider or narrower. So whether it stretches out to look like this or whether it goes this way. So it says as A gets bigger, the parabola gets stretched narrower. So as A gets bigger, we're going to end up with a shape like this. If A gets smaller, we're going to get it being reduced and it gets wider. Q. Our Q value tells us the y-coordinate of the vertex. Q is also the minimum value if the parabola opens upward, or the maximum if it opens downward. Our P value determines the x-coordinate of the vertex and also allows us to find the axis of symmetry at x equals P. Very useful information is the fact that the coordinates of the vertex are P, Q. Let's have one more look at that axis of symmetry. The axis of symmetry is a line through the vertex that divides the quadratic function into two congruent halves. So if I was to fold this picture in half, this would be the crease in my paper. This is called our axis of symmetry. To find the equation of the axis of symmetry, the equation will always be x equals P, where P is the coordinate of our vertex. Our vertex is this point down here. And if we look at the coordinates of V, we would have 5, negative 4. And so our equation of axis of symmetry is x equals 5. Or it is the line where x will always be 5. Example number 1. Sketch the graph of quadratic functions in vertex form. So if we're given the equation of a quadratic function in vertex form, we will be able to graph that equation. First of all, we need to make a list of some of our information. The first thing that we can do is find the coordinates of our vertex. Remember that this is the P and Q value from our equation. Here's our P and here's our Q. Remember that the standard form of this equation is y equals a x minus p squared plus q. So we need to ask what value would we substitute in here that would give us a value of x plus 1. We would have to put in negative 1. Our q value comes from the end of this equation, which is negative 3. We also want to look at what the direction of opening is. Our direction of opening comes from our A value. If A is positive, our parabola opens up. If A is negative, our parabola opens down. So in this case, we open up. Those are the two that we need in order to start our sketch, and then we can find the rest of that information in a moment. Start by graphing your vertex. We want to go negative 1 in the x direction and down 3, so our vertex will be located down here. Our parabola opens up, meaning that it is going to go in this direction. Because we are just looking for a sketch, we don't need to be super accurate with how wide or how narrow those arms of the parabola are at this point. This question asks us to find some additional information. It asks us to find our domain. Recall that the domain is all values that x can be. These arms of the parabola will continue going in this direction and getting wider and wider, eventually encompassing all of our x-axis. So that means that x can be any real number, so I can write it as x can be an element of R, or if I'm writing it in interval notation, negative infinity to positive infinity. The range is the values that y can be. If we look at our parabola, y cannot be in this area down here. So the smallest value that y can be is -3. The largest value that y can be, well, because those arms continue to extend in an upward direction, y can get infinitely large. So y can go up to infinity. -3 is included in our interval, so we use a square bracket. Because we never really reach infinity, we use a round bracket for the range. The last thing that it asks us to do in this question is the equation of the axis of symmetry. The axis of symmetry will always have the equation x equals p. P for this question is -1. So x equals -1 is our axis of symmetry. Now we may need to be a little bit more accurate with how wide or how narrow those arms open up. So I'm going to erase the top part again, and we're just going to back up a little bit and look at how do we decide where those arms go. I want to pick a value for x. So I'm going to let x be equal to +1, and I'm going to find my y value. To do that, I want to substitute x equals -1 into my equation. So I end up with y equals 2 times 1 plus 1 squared, take away 3. Continuing to simplify, I get y equals 2 times 2 squared, take away 3. Y equals 2 times 4, take away 3. Y equals 8, take away 3, or y equals +5. That means that when x is equal to +1, our y value will be +5. So it will cross way up here. So in fact, it's much narrower than what I originally drew. We could find a corresponding point because we know that our axis of symmetry is located directly in the middle of our parabola. And so at this point, if we are 2 units over to that arm, we will also be 2 units in this direction. Will tell us where this other side crosses. Let's look at one more example. This one is y equals -1/4 times x minus 4 all squared plus 1. Again, our starting point is our vertex. The vertex comes from our p and q values. So our p value is +4. Our q value is +1. Now let's mark our vertex on our graph. So over 4 in the x direction and up 1 means that our vertex will be here. Let's look at the direction that our parabola will open. Because our a value is negative, means that the direction of our parabola will be opening down. So from this point, I know that my parabola is going to open in a downward direction. Let's find another point to help us draw a little more accurate graph. So let's let x equal 0. If x is 0, we're going to substitute that into our equation. Okay, here's 0 for x. and then solve to find our corresponding y value. So y equals negative 1/4. 0 minus 4 is negative 4 squared plus 1. Y equals negative 1/4. Negative 4 squared is 16 plus 1. Y equals negative 1/4 times 16 is negative 4 plus 1. So our corresponding y value will be negative 3. So when x is equal to 0, y will be negative 3. So our parabola is going to come from here and come through this point. Again, we could find that similar point by looking at our axis of symmetry. From our axis of symmetry to the point that we just found is 4 units. Therefore, 4 units in the other direction will give us a similar point in order to make our graph a little more accurate. That similar point would have the coordinates of 8 and negative 3. The equation of the axis of symmetry will be x equals positive 4 because it goes through our x value at positive 4. Our domain the domain of this function is what values can x be, and the same as our last one, x can be any real number, or in interval notation it can go from negative infinity to positive infinity. Our range is the values that y can be. This time, y has a maximum value. That maximum value is positive 1. It can get as small as negative infinity. Again, because we don't reach infinity, we'll use a curved bracket. And because we can reach the value of negative 1, we'll use a square bracket on that end.